then. Let's do a practice problem with parallel. See if we remember what to do, how to solve. And here we go. 3 volts. There you go. 3 volts, 500 ohms, 1.5K, 150K ohms. Here are the rules for parallel. Still Ohm's law, no problemo. And if you're wondering why we haven't done anything with power yet, we will when we get to series parallel. Because we know the rule for power is always additive, done the same way, and we're going to practice then. We'll go over that practice problem. Pretty safe to say that your REQ or your R total, straight up parallel circuit, R total and REQ are the same thing. It's probably going to be less than that, 500 ohms. Smaller than the smallest. I remember. It's on the board. I remember to write it down. We have an REQ yet? Mr. Salmon, what you got?
374.06 ohms.
334.06 ohms.
374.
What the hell? Am I dyslexic in the ear? I'm being physically abused in the ear. Did you say 374? All right. I don't know. Something's wrong with it sometimes. Only a little crazy. How about I total? Mr. Hedger.
555.56 microamps. Oh, I read the wrong one.
That looks like that one. I was like, there's no way I picked the right numbers to come out exact.
8.02 milliamps.
What is it?
8.02 milliamps.
8.02 milliamps. All right, then. The cool thing about a parallel circuit is we can find branch currents before we find total current, huh? You can't, because voltage is what? Parallel. Right there, common. So I can take that 3 volts, apply Ohm's law, bam, 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 done, add them up, I total done. Do it. Kelly, what's IR1? Since you're laughing at me like you want something. 6 milliamps. All right. Mr. Whitmer! IR2, 454.
IR2 is
3 volts divided by 1.5K.
2.
2 what? Cow patties? What?
No, milliamps.
Okay, 2 milliamps. Is that right? Everybody else? Okay. And Mr. Schill, IR3.
20 microamps.
20 microamps. Look at these branch currents. Does it make sense that the largest branch resistance has the least amount of current? It should, because hello. It's a relationship between current and resistance, right? Ohm's law? Yes! Amazing. So if I add these together, that's basically what I get. 8.02 micro per milli, because I got micro, and that's going to carry out like that. As such, yes, I agree with that. How do you like them apples? Can we handle the parallel circuit finding parameters? All right. So I've already discussed adding a branch. And let me show you what that means. That means I come over here and I physically add R4. And I don't care. I can call it 100 ohms. Doesn't matter. The fact is, if I add another branch, current's going to increase. I guarantee. So what's the new REQ? Now I've got 100 ohms, and guess what? It better be smaller than what? Better be smaller than 100 ohms. Smaller than the smallest, right there. I keep saying smaller than the smallest. Why do you think I keep saying that? Yeah, you better know it. You better be able to recognize that and know what it means. So the new R total or the REQ, same thing, 78 point what? 91 ohms. Well, our total circuit current was 8.02 milliamps. What is it now?
38.02 milliamps.
Is that like a significant increase? Didn't we just prove if I add a branch in parallel, the circuit current's going to increase? Yes, there's the proof with numbers. Solid parallel. Good? Yep, easy day, easy stuff. So not only do you have to be able to calculate the parameters, because that's basically what the EL will say. We didn't go over it because there's like, most of them say characteristic this, calculate parameters that, because that's what it is. That's what the rest of this boils down to, characteristics of the different types of circuits and calculate parameters. That's what the ELOs say. So it's all fine and dandy to be able to find the parameters, but you better know characteristics too. You better know that, hey, Kirchhoff says the sum of all the voltage drops in a series circuit equals source. You better realize if I add resistance that the total circuit current is going to decrease. What makes a series circuit? G, one path for current. Characteristics you need to know too. Same thing with parallel. Sum of all the branch currents equals source. You better know that, along with calculating parameters. Don't let the switches freak you out. Just because you see a switch in one of the branches, as long as it's closed, consider max current in the circuit, or that branch, that is. If I add a branch, we just proved it. Total current in the circuit increases. We just proved all this stuff and talked about it. Know the rules. The next topic is series parallel. Isn't it just taking a series portion and parallel, putting it in one circuit? Yes, that's all it is. Rules still apply, but you have to know both or apply both to solve. So any questions on parallel